do anything wrong. So once again, to roll through this real quick, when we're adding, subtracting, and working with fractions, what happens here is this is stuff you guys all know how to do. For example, if I'm looking at just this one, in order to add fractions together, what do you have to have? The common denominators. Denominators have to be the same. In this case, they are the same. They're both 3x. So you can write this as, I can write this as 3x, and then I just combine the top and I get 9. What simplifies? 3's. So the 3 simplifies, you get 3 over x. And that's okay. All right? Notice, I'm simplifying because it's monomial stuff. It's not over addition, anything like that. All right? Same thing goes for when it changes up then, if you have to get a common denominator. When you have to get a common denominator, you're looking at stuff like this. Again, this isn't anything you haven't done. It's just we're going to start throwing in there with some variables and things. So when you're doing a common denominator between a 3 and a 2, how do you get the common denominator? Just multiply them together because it's what they call the least common multiple. Least common denominator, least common multiple, that kind of stuff. You multiply those two together, 3 times 2. I'm going to write it out like this for right now. Fraction on the left has what number? Fraction on the left has the 3. It needs the 2. So it's 2 times 2. Fraction on the right has the 2, needs the 3. So 2 times 2 plus 1 times 3 is? And there's your answer. Okay? That's how that stuff works itself through. Like I said, when you did those things, that's in essence what you were doing. And I kind of wrote it out a little bit more of a long form when you're dealing with numbers, because it's kind of easy that way. But it started to change itself up when you started putting together with some of the variable stuff. For example, one of these things here. This one, do I need a common denominator? Do I have one? Yeah. I have one. So in this case, I don't have to do anything but just to write x plus 5 as my denominator, and then I combine the stuff up top, 2x plus 7. Is there anything left to do? No. No. I cannot do anything else because those are separate terms. Okay? There's the plus sign between them. I cannot do anything here at all. All right? There's nothing left for me to do. And then I would go on to the next problem. As you get into the next ones, then you have to start worrying about denominators. And this is where things probably got a little weird. So when you're looking at stuff like this, you always start by factoring your denominators to figure out what terms you have, and then you build backwards. Okay? So if I'm looking at my denominator here, I have 5 and I have a 6x squared. There's really nothing I can do with that one. And then in the other one, I have x over, well, I can factor out a 4x, and I'm left with x minus 3. Everybody okay with me on that so far? All right. Before I go any further, this is when I start to piece together my common denominators. I worry about doing the denominator stuff first. Okay. If you notice, well, what do they have in common? They have one x in common, correct? So they have one x in common. What's the common denominator between a 6 and a 4? What's the next number they go into? 2. Go into? 12. Least common denominator. You're not wrong with 24, but you'd have to simplify later. You always want to get the smallest stuff, okay? So this would have to be a 12. The reason why we got that as a 12, this is where you guys probably started doing this. This was a 2 times a 3. This was a 2 times a 2. Well, what do they have in common? They both have a set of 2s, so you would have 1, 2. Then you multiply it by what's left, 3 and a 2. So 2 times 3 times 2 is 12. That's where that comes from. All right? Now, we start filling in the rest. You have 1x, but this one has 2, so it has to have 2. And the last little bit is the x minus 3. That would be the least common denominator for both parts. All right? That's where that comes from. Well, there's 1x, then you just have to put everything else that's left over.
I don't. Like just.
What do they have in common? They have 1x.
1x.
Okay, so that was taken over there.
Okay.
All right, then what's left? Well, if you go back down to the idea of this is x times x, they have 1x in common. I wrote it down. They had a 2 in common. I wrote it down. And then what was left? Well, 3, 2, that's where I got the 12. X times the x gives me the x squared, and then the x minus 3. That's where everything's coming left over. All right? Fraction on the left. Well, 6 times what is 12? 2. It has x squared, so it needs a 2, x minus 3. Oops. You guys have all done fractions before, right? Yes. This is not anything new. It's coming out here. You guys all did fractions. You guys have all done fractions. Believe me. Okay? 4 times what is 12? 3. Okay? It has an x. It needs 6, another x, and then x minus 3. Oh, that's not 6, it needs 12. I'm sorry. Oops, can't write. Excuse me, this was the x. It had the 4, so we needed the 3. Oh wait, I already has the x minus 3. I'm sorry. This is what happens when I'm not here on Friday. I get screwed up. No. Okay. So,
doesn't it need another x?
Oh, I thought I wrote that. I erased it, sorry. So now you've got 2x minus 6, and this is all times 5. So that's 10x minus 30, and this is plus 3x squared. 3x squared, 10x minus 30, all over 12x squared, x minus 3. You're done. I can't hear over 2 people, so give me a second to answer her question first. What was that?
Is that like a wall?
Yeah, you always combine like terms, multiply and combine like terms. Always. Numerators, you always combine like terms and you write it out. And then you were saying, do you have to do something with that? Sometimes there might be a GCF. If you actually use the 24, you might have to pull some of that extra value out. But other than that, that might happen. But other than that, that's what it goes for. Okay? All right, let's backtrack. Make it easier. Make it easier. What do they have in common? That's not in common. What do they have in common? X. You always start with what do they have in common. You write it down. What's left? What's 5 times 3? 15. Okay? Fraction on the left has the 5 and the x. What does it need to be multiplied by? 3. Fraction on the right has a 3x. What does it need to be multiplied by? 5. What's 21 plus 40? Yes, sir.
That previous problem with the 3x squared plus 10x minus 30, could you draw 3 out of the top?
Can you get a 3 out of 10?
No.
I mean, you can, it's just not going to work.
It's a Monday.
I got you. Okay. Same thing. Same idea. Subtraction. You do the same thing, but as you're writing the problem down, factor it. In order to do any of this stuff, you got to have it in factored form. It's basically what you're trying to do. You're doing prime factorization, but with polynomials. Okay? You're doing prime factorization like you did with the 6 and the 4. But in this case, you're just doing it with polynomials. So as you factor it through, you have x plus 1, x plus 2, x plus 2, minus 2 over x plus 2, x minus 2. So, in the denominators, what do they have in common? Okay, they have an x plus 2 in common. I'm going to go back to how we did this, or how you should have done this long time ago. They have one thing in common. You write it down. Bless you. What's left?
X plus 2 minus
There you go.
minus.
Okay? That's what's left. There's your common denominator. First fraction. It has 2 of the x plus 2's. What does it need?
X minus 2.
There you go. Bless you. Fraction on the right has a plus 2 and a minus 2. It needs another x plus 2. FOIL out the top, combine like terms. We get x squared minus x minus 2 minus 2x minus 4 as you distribute all that out. You wind up with, for your numerator, x squared minus 3x minus 6 all over. Your common denominator. If you want to write it as x plus 2 quantity squared, that's fine. Yes, sir.
Do you want to like FOIL out?
Never. Never worry about the bottom. Always FOIL out and combine the top. All right. Whenever you're adding and subtracting, always FOIL out and combine the top stuff. Never worry about the bottom. I FOILed x plus 1, x minus 2, and I distributed negative 2 to the x plus 2, and I wrote it all down.
What section?
Fine. Yes, sir. There's no reason to. There's, honestly, you could. Some textbooks give you as an answer like that, but it's just a waste of time. There's no reason to. No reason to. Yes, ma'am.
I feel like the
The what ones?
like no offense, but you start with like the worst stuff.
Yeah, I do that.
I'm like, okay, like that.
I do that sometimes.
No.
I do that.
That was
I know, it's no offense, Dave. That's funny. I do that sometimes. Yes, sir. We will. We will. Okay. Again, same idea. Shh, guys. Backtracking again. Yes, you do. What do they have in common? Do they have anything in common? You can't break that apart because of subtraction. Those are terms. Think of the. All right, they have nothing in common. All right.
Yeah, 0.
Guys, just stop yelling stuff out. It's kind of annoying. They have nothing in common. Your denominators are terms. Think of those as terms. Okay. There's nothing in common. So you have to put them together. Fraction on the left needs the 1. Fraction on the right needs the. There you go. Distribute, combine like terms on the top, and rewrite. You're done. Like I said, don't worry about multiplying out denominators. Okay? You don't need to worry about that. Yeah. And that's where a lot of you guys mess up. Forget that there's a negative there. Okay, so it's minus the 6. Excuse me. Yes, ma'am.
If you like the last problem that had 2x, you should just do x plus 2 squared.
Sure, that's fine. Yeah, that's fine. I normally don't do that because I already have 2 of them. That way I don't forget that it's exact.
Yeah.
You know what I mean? Because you can get lost in it. All right, you get lost in it. All right. And then this is where the audio got bad. The audio. Stop being so negative. You got to range. Okay. Remember flex pass. What's there for? Okay. Here, you've got what's called a complex fraction. All right. Complex fractions is just a fraction divided by a fraction. Okay. When you have fractions, When you have fraction divided by fraction, you would multiply by a reciprocal, correct?
Yes.
Okay. When they're written out in this setup, you have to first get common denominator for that bottom fraction. Okay? As you go through that, you do the same process. They have nothing in common because those themselves are terms. So you have to multiply them together. Okay? X times the x plus 2. That bottom fraction, the one on the left, has an x plus 2. What does it need? X. Fraction on the right has the x. What does it need? Distribute combine like terms of that numerator, rewrite. Okay. And you should get 3x plus 4. That top numerator, that top fraction, it's all set up. You just bring it all the way over. Keep, change, flip. What simplifies? Your x plus 2's. And you're done. I cannot simplify that any further because of the plus sign in the denominator. I cannot combine anything else because of the plus sign in the denominator. The only thing I could do is if all those numbers were even. What's 2 times x? I got you. All right. It's the idea that you have these complex fractions. They're not. They just look awful, but they're not tough to work with. Okay. Bless you. All right. No, we'll get into 96 here in a minute. Same idea. Complex fraction. Sorry, that's supposed to be a 4x plus 12. Complex fraction. As you're writing it down, do you notice anything you can simplify as you're doing that? In this top one, these are all divisible by 2, aren't they? Okay. So as I'm starting that one, I would have probably written down 1 over 2x plus 6. I would probably have done the same thing down here. Then I'd have 2 and then x plus 3. Everybody see that from this part?
Yeah.
You just write it down. Don't they have common denominator?
Yeah.
So do you have to get a common denominator? No. What's 2 plus 1?
3.
Okay.
Don't you have to divide it?
I did.
Yeah.
Just one term, because these are separate terms. Okay. So here, this becomes 3 over x plus 3.
What happens to the 2 you take out? Nothing, it's just gone. It doesn't.
It's gone because it's just a factor. Okay, you're simplifying. You can simplify that out as a factor, as a simplified version of 1. Okay. So now you've got your fraction divided by fraction. 1 over 2x plus 6 times x plus 3 over 3. What's the 2x and 6 have in common? The 2. So This is the same thing as saying 2 times the quantity x plus 3. That's multiplying now, isn't it? Once I get to multiplying, what can simplify out? The x plus 3's. What is your numerator now? 1. What's 2 times 3? Is that 2 and a 3, or I should say, are those 2's and 3's in that denominator there wearing life jackets? They're not wearing life jackets, right? Are they wearing life jackets?
No.
So they don't float up.
Oh.
A lot of times, I guarantee 3 or 4 of you will try to let that denominator float when the numerator is 1. It's a very common mistake. That's why I asked.
Oh, they'll make it like, wait, so is this still instead of 1?
Started that, yeah. Yes, sir. No. What I'm saying is that a lot of times when your numerator becomes a 1, people let the denominator just float up. They just forget. That's why I'm saying make sure you remember where it is. It's in the denominator stays there. What do you mean? Sorry. This. All of that.
All of them? Okay.
All right. Last one of these because I want to get into the equation stuff real quick. So again, in this instance here, as you're going, is there? I mean, you can look at it right away. Is there anything that you can factor? No. What should you put underneath the 5? What should you put underneath the 8? Okay. So as you're doing this, you know that this is over 1 and this is over 1. So I would be getting my common denominator right away. Okay? Fraction on the left has 5. So I just write down what's in the numerator, x plus 2. Fraction on the right needs the 5. So I write 5 times 5. I simplify that numerator and I get x minus 23. Okay? I do the exact same thing at the bottom. The next. What I have. Yes, sir. Common denominator. This one has the common denominator between 5 and 1 is 5. Okay. What's 5 times 5, guys? 25. So 2 minus 25. Fraction on the left needs the x, fraction on the right doesn't. Okay. Bless you. Bring that over. Bless you. In this case here, there's nothing that I can simplify. So my numerator just becomes x squared minus 23x. My denominator would just be 5 times 8x plus 4. There's no reason to multiply it out. You can't. You get 40x and 20, or if you took it out, you'd have 20 times the quantity, 4x plus 1. Yes, sir?
If we factor that by 40x plus 20.
That's fine. No, it's fine. All I'm saying is that whenever you're doing these things, you don't have to FOIL out or do anything with the numbers.
Okay, so if we like.
Hey, I'm not going to yell at you, and you're just at that point. Remember, you're just wasting time if you think of it that way. All right, because there's only so much time to do these problems. All right, that's kind of what we're doing. Now, the other part of it that I want to look at real quick is now, what do you do when you have equations with it? This again is stuff that you guys have all done. This is not new whatsoever. The only thing that's a little bit new is maybe the extra part of factoring that gets thrown into it. This equation is quite literally the same thing that you saw in an Algebra 1 textbook. Okay? And you guys have actually done these things before where you try to get rid of your fractions. So what you want to do is, how would you multiply everything, or what would you multiply everything by to get rid of the fractions? If I multiply it by 3, I don't get rid of the 4, though, do I? 12. So if I multiply everything by 12, and I'll do this long form so you can see what's happening here. It means you're multiplying this, all 3 pieces, so you get 12 times x over 3. 12 times x over 4. 12 times 7 over 4. What's 12 divided by 3? 4. All you're doing is by multiplying by a common denominator, it eliminates the denominators. They're all gone. When you have equations, if you multiply one thing to one side, you have to do it to the other to keep it balanced.
Wasn't one of them on the left side next to or next to or not next to? Because an x over 3, or 12 times x over 3 plus 12 times x over 1.
It's a 4.
Oh,
7x is 21. Sure. What's the common denominator? 3 and 4. Keep things balanced. Same idea. What's the common denominator? It's going to be 15, isn't it? Okay. You have to multiply everything by 15. Well, 3 times what is 15? 5. So you get 5x. 5 times what is 15? 3. So you have to multiply that by 3. Okay. Sorry, that's a bad parenthesis. Again, distribute, watch your signs. 5x minus 3x minus 6 is 30. It's slipping my hold my hand forever. Oh, right. Yeah. Get rid of the fraction. You guys have all seen this. What changes now? Okay. It's not 4x. What's the least common denominator? 2x. I want to multiply everything by something to get rid of it. I want to get rid of my fractions. To keep things balanced, I want to keep things balanced, so I'm going to multiply everything by 2x. Okay? Real fast, what can't x be? 0. Why can't it be 0? Can't divide by 0. Good.
So do I just multiply whatever fraction plus fraction?
No, because you still have something on the other side. You want to eliminate all fractions. What's the easiest way to get rid of all fractions? Multiply everything by 2x. Okay? So if I do that, again, go long form. 2x times 4 over x plus 2x times 5 over 2 equals 2x times negative 11 over x. Each one of these becomes their own division column. Your terms simplify out. The x's go away. The 2's go away. The x's go away. You're left with 8 plus 5x is negative 22. And you get negative 6. Okay. I'm really surprised that you guys are this in awe of this because you've done this. You've all done this. Just that FYI. I mean, I know you guys, in order to pass Algebra 1, you did? Oh, wait a second. Yeah. X is negative 6. Subtract 8 divided by 5. Okay. What changes now if it gets two terms? Now I have terms in my denominator. Okay. When you have terms, same basic idea. I want to multiply stuff to get rid of fractions. Now, right off the bat, you should recognize what can't x be though. It can be 0. It can't be 2, because if it was 2, it would make my denominator 0. Okay. 0 is an okay answer for a problem like this, but I'm just saying that you got to make sure that if you get 2, it can't be 2. Okay. It's an answer. It's called excluded value. So here, you'd multiply everything by x minus 2. When you do that, you have 5x equals 7 times x minus 2 plus 10. As you're bringing that factor over, that x minus 2 to each one of those terms, 2 of them simplify out because you're getting rid of the fractions. There are no more fractions. 5x, 7x minus 14 plus 10 would be minus 4. So 4, but we got 2 for our answer. It can't be 2, so it's an excluded value. So this is a no solution. It's no good. Okay, it's an answer, it's just not an answer. It's an excluded value. Okay, there's a reason why that happens graphically. We just haven't done the graphs yet. When we do the graphs tomorrow. If I put 2 into there, what do you get for your denominator? 0. Can you divide by 0? That's my excluded value. Now the easiest one is one you guys have done hundreds of times. In this case here, isn't that just fraction equal fraction? What do you do when you have fraction equal fraction? It's the only time you have to worry about it. Cross multiply. You get fraction equal fraction. So in this case, excuse me, looking at this problem, before you get too far along, you can do fraction equal fraction, you can just cross multiply on this one because there's no tack on like plus 2 or anything like that on the other side. It's just straight fraction equal fraction. But when you look at it, right away, what can't x be? 1. Could it be negative 1?
Yes. No. Yeah. No.
Well, I'm asking you. What's negative 1? What's negative 1 squared? 1. What's 1 minus negative 1? 2. So negative 1's okay. It just can't be 1. All right? All you're doing is cross multiply. Distribute, set aside equal to 0. 2x minus 2. Okay. And then I move that over. I know you're not copying somebody else's page right there, right? You want me to take it? Put it away. Move it over. Oh, I'm sorry, it's minus, sorry. So it's minus 3x plus 2 equals 0. What times what's 2? You add together to get negative 3. Negative 2, negative 1. So your zeros are at 2 and 1. And 1 doesn't work, so what should I do to it? I just cross it out. It's an answer, which is not an answer. Okay? It's an excluded value. And that's where that comes from. You guys have been doing cross multiplying forever. All right triangle trig, sine of something equaled 4/5. You cross multiply, you did all the inverse stuff. That was all that was. It was all cross multiply. Been doing this for a long time. Okay. On 9-6 then, I forgot what page it was, but I think it was numbers 30 and 31, or is it 31, 32? I don't remember. It's on the page here. Let's see. 31, 32, then do 45 through 50, 9-6. We will start doing the graphs.
45 to what?
50. We'll start doing the graphs then tomorrow. Honestly, I don't see why we shouldn't be done with this by Friday. It is a rather quick. Depends on how graphing goes. But at the very earliest, we would test on Friday. The very latest, we would go on Monday. Okay. Earliest would be Friday. The latest would be Monday. I hate to do the Monday thing, but this might be the one time the entire year it has to happen, just so we get it all done. Okay.